welcome to NDC Sydney. I'm JK from SSW, and here I have Matthias, a machine learning and Fsharp expert. He done a workshop just a couple of days ago, and he's an avid Dungeons and Dragons player. So, would you mind to introduce yourself?
Sure. Good morning, JK, and thanks for the introduction, and thanks for having me. First is it's my second time at NDC Sydney, and the city is awesome. And one of the things I love about it is coffee is absolutely stellar. So just for that, I'm happy to be here. And otherwise, I'm known as there are a couple of things people know me for. I do a lot of Fsharp and functional programming. I do a lot of machine learning professionally and for fun. Another thing you might have picked up from my accent is that I do live in California, but the original accent is actually from France. And I figured the workshop was about Fsharp and machine learning, and JK, you are interested in the topic, and we had a lot of good conversation. So how about we maybe dive more into that topic?
Oh yeah, I really enjoyed the workshop, so I'm really looking forward to for that.
So given what we had been talking about, is how about we revisit one of the earlier problems we looked at, which was recognizing digits.
Oh yeah, I really like the demo. It's basically showing how you can use machine learning very easily, even for someone who hasn't done Fsharp in the recent years. So let's go.
So let's do this. And thank you for making that point, because one of my battle cries is something machine learning is not that complicated, and one of the things I don't like is a lot of times people present it and it ends up looking this is magic, things happen, and you have no idea how this works. And if you start to open the box, it turns out that it's actually not that complicated. So how about we take that thing and look at building a system completely from scratch and see no neural networks, no magic involved, and see if we can get somewhere.
Okay.
So the problem we looked at was it's a very classic problem. It's using the MNIST dataset, and the goal will be to do something let's take an image. Where a human has written a number, which could be a 1, could be a 7, could be a 9, whatever. And the goal is, can we decide what this image is automatically? So to do that, machine learning, there is one ingredient you absolutely need, and that is data. So we do have data. So we have a magnificent CSV file, and our CSV file is 5,000 images, where I know what the image is. This image here is a 1, and then I have all sorts of pixels. I have the second image is a 0. I have pixels, and so on and so forth. So if I look at this, it's this is great. This is data, but this is not very usable, or I can't really see what's going on. So the first thing, exactly. This is one of the first problems you have in machine learning is you start with a file full of numbers, and what you want is to do something with it. So first step is how about we just read the data. So here I'm going to use VS Code, and I'm going to use my weapon of choice, which is Fsharp. So first step is we have data in a CSV file. We want to load them in memory. Let's just do that. So it's going to be pretty straightforward. We're in .NET, so open system, system.io. I'm going to create something which I'm going to call an example. This is the data I can use to learn. So an example will be I have a label, and the label is telling me this image is a 6, this image is an 8, whatever the image is, and then I have a bunch of pixels.
And this is in C# types, so you just define types on the fly.
That is correct. It's pretty close to what you would do with the class on the C# side. It's immutable, it's net and tight. And so now what I want is take the CSV file and transform it into a bunch of these things or a bunch of examples. So I'm just going to write a function. And as you can see here, all I'm doing is I'm not building, I don't have a build script or anything. All I'm doing is I'm taking my code and running it straight into the scripting environment. So I can see what's going on, I can test my code and all that type of thing. So here I just wrote the function ahead of time because that's a bit faster this way. And so what I really want to do is I want to say, if you give me a path, which is a string, where my file is, I'm going to read all the lines. I'm going to skip the first one because headers are not really data. I'm going to split on the comma, and I'm going to transform everything in integers and shove this into examples. And so here we go. And now I can just read my data.
Yeah, it's really, really interesting to see how this is solved in Fsharp, because you would probably take at least 10, 20 lines to write all of that. Now here you have a readable way of seeing what's going on, how the data is get transformed, and I can really see how this can help you doing machine learning a bit easier.
Yeah, like the first piece, I think, is the scripting environment. Just being able to load the data and not have to load it over and over and over again is nice. And then the type of workflow you see a lot. I mean, in the end, is like machine learning is a lot about transforming data into something else. And so you have a lot of things which look like a pipeline. And as it turns out, is like Fsharp has a pipeline operator built in, like this little arrow here. And so you can see immediately what's going on. Is like I'm doing this, then this, then this, then this, then this. I can just see all the steps. Like one of the things I really enjoyed back in the days in C# was link, which I think is one of the most beautiful features of the language. And like if you come from C# to Fsharp, one of the ways to think about it is for me, like Fsharp is as if you were writing 95% link and a bit of object-oriented. Like it's something like this. So now it's like I have data. So as I said, it's like numbers are nice, but like they're not really, it's not that easy to see what's going on. So maybe what I'm going to do is I'm just going to show you a bit how the data looks like. So I have a tiny function here. And what I can do is I can take one example and draw it. So for instance, let's say like the first row of data I had, and let's run this and see what this looks like. So what this is like it's supposed to be a 1. Part of the point is like it does look like a 1. It's been written by a human. It's not particularly clean. So the point I'm making here is like the task we're after is not completely straightforward. It's not like a nice letters coming from a book. It's what humans write with. So it might be written nicely, or it can be written by your doctor, which is illegible. So that's what we're trying to do. We're looking at these images, and the question is, just by looking at the data, can I decide this is a 0 automatically? So how could we do that? Well, we could do lots of things, right? It's like if you're to trust like talks on machine learning, is like what you should be doing is like using neural networks and all these things. Neural networks are great. They are a huge tool for a tiny problem sometimes. So how about we try to solve that the old-fashioned way, completely by hand?
Yeah, I know that most of the developers I know, they will just try to use custom vision APIs on Azure or other providers, just upload the images and hope for the best.
Yeah.
But let's see how that's actually work if you try to do yourself.
That's right. And if we, let's see how far we go by using 0 libraries, 0 APIs, and just like think a bit about the problem. So if I think about the problem, is like what I'm trying to decide is like I'm trying to say this image is a 0. And the question is, so how do I know it's a 0 as a human? I know this because it has the right shape. Another way to think about it is like I know this is a 0 because if I compare it to something else, for instance, like a 1, let's look at a 1. Like the way these two images are different is like the pixels are quite different. So a way to restate the problem would be, can you find an image which is similar to the image I told you to recognize? And if the two images are similar or identical, the distance between them is going to be very close to 0. Like every pixel matches, then the image is the same. If I have a couple of pixels which are different, it's maybe not that similar. And if every pixel is completely different, then it's very likely not the same image. So one very simple thing I could do, instead of using a neural network or like whatever library you like, is to make the following statement, is that you give me an image. I happen to have like 5,000 images already. I know what they are. How about I take these images, look at them pixel by pixel, and the further apart they are, the less likely they're a candidate, and the closer they are, the more likely they are the right answer.
Yeah, and to be clear, the distance just means that you take 2 pixels from different images, you calculate the difference, and then you just do the square roots and stuff like that. The math will show later.
That's right. Is really what I'm saying is like here are 2 images. Look at the 2 first pixels. Are they the same or they're very different? Second pixel, same or different. And if every single pixel of the 2 images is close, the images are probably very similar. If they are far, I will have like big differences. So if I sum this together and compute the distance pixel by pixel, I should get a good sense. This is similar. This is different. So let's do that.
Yeah. So in a sense, machine doesn't even know how different the images are. It just knows it's quite a bit different or little different.
Yeah, and that's kind of the fascinating part because, again, like machine learning tends to look a lot like magic. And you end up thinking like there has to be a brain or like there has to be a lot of smarts in the machine. And in the end, like typically what the algorithm does is like it tries to recognize those patterns it has already seen. And if you see something which is similar to what you want, it's probably the right answer. That's all it does. It's just like when it works, it looks like surprisingly close to magic. What is it like the quote about like any sufficiently advanced technology is indistinguishable from magic is pretty much what's happening here. So let's write this distance function. So what we want is like we want something which is take 2 images. For each images, like take pixel 1, compare them, pixel 2, compare them, and do the sum of this. So I did that here. what I'm saying is like I'm going to have a distance function. My distance function will take two images, like an array of ints and an array of ints. And I'm going to take them both. For each of the pixels, I'm going to compute the difference, so how far they are, and I'm going to compute the absolute value and sum that together. So let's do this, like 3 lines, not too bad. And now is like what I should be able to do is I should be able to say, fine, take 2 images and tell me how far they are. So a first test is like an image should be completely close to itself. Like if I take the image 0, the distance to the image 0 should be 0. That's what we're getting. So again, like the scripting environment is nice. I can test that. I don't know it's right, but now my code is not blatantly wrong. So I might be on the right track. So now is like the first image in my data set was a 1. So, and the second image was a 0. So let's see how far apart these 2 images are. And if I do that, I'm getting a distance which is like 49,000 something something. And I know that image 1 was a 0 and image 4 was a 0. So let's compare these 2 things and just see what happens. And what I'm getting now is I'm getting a distance of 13,000. So what this is telling me here is like image 1 is much closer to image 4 than to image 0. So if I had to pick what is it, is like I would probably say like 1 and 4 are the same thing and 1 and 0 are not the same thing. So now we pretty much have everything we need to build a machine learning algorithm. So shall we do that?
Yes, we shall.
Let's do it. So suppose I want to classify an image. So I want to decide, is this image a 1, a 0, a 2, and a 7? So I'm going to do let classify. What am I going to classify? I'm going to take an image in. So it's going to be like an array of ints again. And all I need to do is I need to take the data I just loaded, which is my training sample, like 5,000 images. For each of these images, I want to look at which one has the smallest distance. So I'm going to take the one which has the lowest distance. So I'm going to take each example and say, give me the distance between the pixels from that example and the image you just gave me. So that's going to give me like an example, which is really the best match I have. I have 5,000 images. Now what I get is like the best match, which is the closest image. So now I don't really care about that. What I want is I want the label of this thing. So let's say bestmatch.label, and we have a classifier.
Fun.
Thank you. This is what happens when you live code. Is like, here we go.
It's the first session in NDC, so.
So now we have a classifier. So let's see if this works out. It's like now what I should be able to do is I should be able to take this function, give it an image, and it will give me an answer. So I think I have like a tiny bit of code below. So I'm going to just drop this because it's similar. So what I would like to do is I would like to verify maybe if my code works or like how well this works. So what I'm going to do is I'm going to say, if you give me an example is an image where I know the correct answer. I'm going to say, fine, use the classifier to give me a prediction. So tell me what you think it is, and I'm going to use the same visualization code I used before to actually show you the image, what the image is and what the prediction is. So let's take a look and see if that works out. Okay, fine. And let's run it on like the first image from my test set. So let's do it. And this looks like an 8. And I can see here in the corner, so this is not the best, but the prediction is an 8 so far. I would say like not too bad for like 6 lines of classification code. Let's try maybe another one. What's a number you want to try?
Let's do 77.
77. So I have never seen which one it is. So let's look at what 77 looks like. 77 looks like a 0.
Ah, nice.
And the prediction is a 0 again. So this is like not completely proving that this works, but so far, I mean, I would say like we wrote what, like 7 lines of machine learning, and it works surprisingly well, no?
Yeah, the important thing is once you have the data, and if the data is clean enough, then you can really write your own machine learning pretty easily. Now, this, if I understand correctly, is without a model. So if you try to run it on a mobile device, it's going to be slow. But it kind of gives you the feel for how machine learning works, right? I
would agree with that. It's like the algorithm I'm showing here is like not necessarily the best. Like in the end, all it is doing is like you give me an image, I'm going to compare it to all the images I know, and I'm going to give you the closest match. So there is not really, the model is really like doing a scan of the data every single time. So there is no model to speak of. It might be a bit expensive. It might not be the type of thing you run on your cell phone because that might be heavy. At the same time, it's like it's surprisingly simple. It works. And I would say it's a good starting point maybe to do a model, and it shows pretty well what's happening because other models might be more complicated, like a neural network is going to do more work. A random forest will do more work, but in the end, they do the same thing. What they're trying to do is they're trying to recognize known patterns and decide what you give me is similar to this thing, which means that it has a low distance, and based on this, I'm going to give you an answer. So it's a simple algorithm, but yet it's a good illustration of how machine learning in the end works.
Oh, yeah. And a lot of people, when they think about machine learning, they think about neural networks. But with the workshop that you have shown previously, and with a little bit experience I had with ML.NET, I was like, you can actually get really, really far without neural networks. And I was very impressed by the decision trees, especially when you showed that you can show the actual decisions. And then you can show to the business, hey, this is how the machine learning works. And they're like, oh, okay.
This is music to my ears, because I think like there is a bit of a problem, which is neural networks are fantastic. They do amazing things, but they're also a very heavy tool. And one of the problems is like people really enjoy talking about them because they're fun, but like they're only one of the tools you have in the arsenal, and they're probably the most complicated one you could use in machine learning. And like there is a lot of algorithms out there. You can start with the old school linear regression is there, the trees are there, KNN, like the one I just showed, is there. So there are lots of much easier ways to get your feet wet with machine learning and get results on your own data without going for the heavy tools out of the bat. So I would say like neural networks are great, but don't necessarily start there, and do simpler things which work first, and then is like maybe use neural networks when you need them.
Oh, yeah. And I heard you have also tried to do this in C#, a similar demo. And how does it feel when you went to C# and tried to do the demo that you've done in Fsharp?
Like writing the same type of code?
Yes.
So the first is like, I could do it. Like two comments here. Like the first one is like I wrote Fsharp all the way here. So one thing I want to make clear is like I did an Fsharp script here, but it would take me literally 5 minutes to transform this into a DLL, which I could drop into any .NET code, C#, VB.NET, Fsharp, and that would work just fine. So one thing which is nice here is I can use a tool which is actually convenient for data science, and I can still have something which will integrate very nicely with your .NET code base. That's one of the reasons I use Fsharp, because sure, Python is a nice language, R is a nice language. The problem is like you can do a great model in R, and then it's a good luck running it in your .NET application. Like that's not going to work very well. So Fsharp is a really, really nice compromise for that. Then is like, I have done it in C# as well. And I would say it works. I think it's just the language is kind of less suitable for this, because like a lot of machine learning tends to be like data transformations and functions, and like Fsharp is a functional language, and so it's like in my opinion like it leans itself better for that type of problems. Like you can totally do it. Okay, when I wrote it, like to be clear, is like it worked. It was just like 3 times longer. Like literally code-wise, everything ends up being a bit bigger. So I would say like if you're looking at things like data transformation, machine learning, data science, and you're on .NET, do yourself a service and take a look at Fsharp, because it's magnificent.
Yeah, after 2 days of workshop, I was like, okay, C#8 is actually introducing a lot of interesting features that makes it closer to Fsharp, but that real power of just transforming data, just shipping data around is just, once you start doing it and once you have the right samples, you're just like, actually, shouldn't be this the way you program. You just define how the data is being transformed and people can actually read it.
Yes. I will not fight you on this statement. Like I would agree. Yeah. In general, is like I really like C# as well, and I think both languages have their space. And it's like it's tricky to do language which does everything right. So it's like I would say like use the language which is right for the job or something like this, and like use both, like instead of just trying to do everything in one.
And what I also found is when you working with math, like in machine learning, you have lots of equations. I found that I'm actually better at reading code in terms of what the code is not, what is the mathematical operations that it does, than in math equations. It's basically I understand the code. And if somebody shows me the code, hey, this is how the machine learning works, I'll be like, okay, just give me a minute. Okay, understand it now. But if somebody gives me math, it's just like, I don't even know what those symbols are.
Yeah.
I think we're closing to the end of the interview. So can you show us how can we go forward with Machine Learning Week? Can we find some resources? And I heard you doing some sessions after for Fsharp specifically and deep learning.
Yeah, that is correct. So after having told you that you should not use deep learning or like you should be careful about it, is like tomorrow I will have a talk on CNTK and deep learning. So CNTK is something pretty close to TensorFlow. It's which happens to have like a good bindings for .NET. So I'm going to be talking about deep learning using Fsharp and CNTK. And okay, it's like not really related to deep learning, but I'll be talking also about Dungeons and Dragons on Friday. But otherwise, like if you want to find more on the topic of Fsharp and or machine learning, first, I'm not very difficult to find online, but I would recommend to take a look at fsharp.org, the Fsharp Software Foundation. So fsharp.org is the home for open source community Fsharp. And is run by the community, and this is where most of the active contributors to language hang out. So I hang out there all the time on the Slack channel, talking about data science and machine learning. Other people talk there about web development, whatever topic you want. So people who like Fsharp tend to like to talk about it. So go to fsharp.org and let's start the discussion.
Okay, thank you for this great interview.
Thank you so much for the questions. I had a lot of fun, and thanks for having me on.
And this was the interview with Matthias, a machine learning and Fsharp expert, and I hope I see you soon. Thanks.
Thank you so much.